Today, I'm going to show you how to install VMware RabbitMQ for Kubernetes, version 1.1, onto a private registry, and then use it to create some RabbitMQ infrastructure in an air-gapped network. This version of the product requires components of the Carvel toolchain, which are available on TanzuNet. Specifically, you will need image package, kbuild, kapp, and YTT. Aside from the Carvel tooling, all the files needed to install the RabbitMQ infrastructure are contained in a tarball hosted on TanzuNet. Once you have this tarball, transfer it to your air-gapped network in any way you see fit, such as through a pen drive. Once you have this tarball on a machine running within the air-gapped network, you will need to authenticate with your private registry within that network. Once authenticated with your registry, you should be able to use image package copy to copy the contents of that tarball up into the registry within the network. This process will create several artifacts in the registry of the air-gapped network, corresponding to either deployment manifests or images to use with those manifests. Here we are using the devregistry.pivotal.io as our effectively private network, and you can see the artifacts that have been uploaded to this registry. Now the private registry contains all the manifests and Docker images that you would ever need to deploy any of the RabbitMQ infrastructure. And any clusters within this network do not need to rely on external resources for those images or manifests. They can simply pull from the internal registry. Let's go to another machine that's on this network. This machine has a Kubernetes cluster running and targeted. In this case, it's just a kind cluster, but this could be any infrastructure of Kubernetes. Again, we will need to authenticate with the private registry within this network. Once we have done this, we can image package pull the bundle that we uploaded earlier in order to get those files onto this machine. Contained within this bundle is the OSL, the license for this software, and a README. For the remainder of this demo, we're going to be just following the instructions within the README. So if you prefer this information in a written format, you can check there within the bundle. The first thing we will need to do is create a namespace for our RabbitMQ objects to live in. So we can do this with kubectl. At this point, we have two options for deploying the rest of the infrastructure. We can either use Cert Manager to create certificates that are needed for various webhooks within the operators, or we can create the certificates ourselves and store them as secrets. We highly recommend that you use Cert Manager for this, as it's very automatable and is quickly becoming an industry-adopted standard for certificate management. For the purposes of this demo, we're going to be using Cert Manager going forwards. You can install Cert Manager using the Carvel toolchain by using kbuild to render the manifest of the Cert Manager CRD and operator, and then using kapp to deploy that as an app within the Kubernetes cluster. Next, we're going to be creating the operators. The operators manage the RabbitMQ clusters, as well as the topology objects that are contained within those clusters, such as the users, the vhosts, and the queues. However, the images for those operators are in our registry, which is private, and the Kubernetes cluster is not yet authenticated with that private registry. In this case, we can resolve this by creating secrets within the Kubernetes clusters that contain the authentication with the private registry. That way, when the cluster tries to pull private images from the registry, it can authenticate using the credentials that we provide in these secrets. The Kubernetes website has great documentation on how to create these secrets. In my case, I can just use a one-line command in order to mount my local Docker authentication config on the cluster. I need to do this in any namespace where I plan to create a RabbitMQ cluster, and also the RabbitMQ system namespace. So in my case, I'm going to be creating clusters in the default namespace. So I need one for the default namespace, and then I need to create the same secret again in the RabbitMQ system namespace. Once I have done this, I can use YTT to render the manifests for the operators, pipe that to kbuild to render the images that are used in those manifests, and pipe that to kapp to deploy this as a single app named RabbitMQ operator on my cluster. Once this is complete, we should be able to see two deployments, one for the cluster operator and one for the messaging topology operator. Now the operators are deployed, let's deploy a RabbitMQ cluster. I'm going to be using this sample manifest for a RabbitMQ cluster called mytanzurabbit. Once again, we use the Carvel tooling to deploy our manifests on the cluster as an app. We will see after some time that the RabbitMQ cluster will be deployed with the reference of the image that is contained in the customer's private registry.